successful to organize 7 seminars, essentially seminars. I'm sure if you stay here, we can organize another 3 to 7 like that. So, yeah, our today's speaker is Dr. Yuko Nakano. She's not a stranger here. She was a postdoc here for 3 years, 2009 to 2012, and she worked in Tanzania, in Africa, and and she did extensive survey on household surveys on rice cultivation in Tanzania. And before joining in IRRI as a postdoc, she completed PhD from GRIPS. Actually, she was my coursemate in GRIPS PhD program. Of course, she was my junior. And before that, she studied in 3 top universities in Japan. And to my surprise, she was studied in Kyoto University, the second top university in second top university in Japan. Kobe University, also one of the topmost universities in Japan, and also GRIPS. And her research area is spatial integration of maize market in Tanzania, large-scale irrigation schemes in East Africa, and she got 2 excellent publications very recently. One is published in Environmental and Development Economics, and the topic is determinants of household contribution to collective irrigation management in Uganda. Actually, that was her PhD thesis. And she got another book chapter, the possibility of rice green regulation in large-scale irrigation scheme in Africa. So today she is going to present the topic on social learning in technology adoption, spatial econometric analysis of rice farmers in Tanzania. So let's give a big hand to Yuko Nakano, and the floor is yours.
Okay, thank you very much, Dr. Motre, for your comprehensive introduction of mine. It's like almost all of my CV. I think most of you knows me. I was working here in Tanzania, in the Philippines since 2009 to 2010. And while I was not here, I was working in Tanzania. And today's presentation is our work, which is based on the data which I collected in Tanzania. This is, in fact, in Tanzania office. It's a small house, but mainly our work is in the field collecting data in Tanzania. Okay. The title is Social Learning in Technology Adoption, Spatial Econometric Analysis of Rice Farmers in Tanzania. And in fact, the work is collaboratively done with me and Val and Kei Kajisa, who moved to Japan also. Okay. If you have attended my seminar in the past few years, I always start my presentation from this slide. And this figure shows total paddy production, area harvested, and paddy yield and import of milk rice and arable land agricultural population in Africa. And what you can see from this figure is that total paddy production increased very rapidly over last 50 years. But when you see the source of this production increase, arable land, area harvested increases rapidly, but paddy yield is not, the increase of paddy yield is quite slow. And the average paddy yield is still less than around 2 tons per hectare in sub-Saharan Africa. And at the same time, when the production increases, but at the same time, demand also increases very rapidly, and imports from Asian countries are increasing in Africa in total. And since population grows rapidly, arable land per agriculture population has already started declining. So we need another green revolution in sub-Saharan Africa. So that's what I'm working on. So how to make another green revolution? And then, when you summarize the essence of Asian Green Revolution, it can be summarized as the rapid increase in the paddy yield due to the adoption of fertilizer-responsive high-yielding modern variety. And this adoption of modern variety came together with such land-saving technologies as chemical fertilizer, bank construction, and plot leveling and transplanting with loss. So, my interest is how this technology diffuse, and especially what is the pathway of the technological diffusions when we are now examining the impact of the social network on the adoption of these technologies. Okay. Okay. And then, sorry, I wanted to show this slide first. Okay. Then, why should we think about the diffusion process of technology and social learning? First of all, to know the how technology diffuses, provide information to improve the technology dissemination process and strategies. So this is very important for the development process. And also, we can, by knowing how technology diffuses in reality, we can provide some feedback to the scientists like leaders and agronomists on the development of what kind of technology should be developed. So we can provide a feedback information to scientists to develop the technologies. And in this specific paper, what is new? I told you that we are working on the social learning. And then, what is new in our study? There are several, quite a few number of papers which deal with the social learning in technology adoptions. So what they discuss is farmers are observing other farmers to adapt when they are adopting new technologies. But several papers deal with that. Okay, farmers are adapting technologies by observing others, but if you give the technology, if they learn technology directly from extension workers, then they adapt more efficient manner in the technology adoption. So what exactly I'd like to examine in this paper is that we are now dealing with a training program which is conducted by JICA, and then they adapted, I will explain it later in detail, but they adapted a new kind of strategy that they train key farmers, they call key farmers, important farmers first, and then they expect farmers to farmers technology dissemination. So what I would like to examine is this JICA approach will work effectively or not. Okay, so this is our study site. We interviewed, in fact, use only part of this data set, but we interviewed 530 farmers in 3 irrigation schemes called Ilonga, Chanzuru, Mugumi in Kilosa district in Morogoro region. As I already explained to you, in 2008, JICA conducted a training only in Ilonga irrigation scheme. And that training is on the basic rice cultivation techniques such as small variety and chemical fertilizer application, transplanting in low and plot leveling, and improved land construction. And then in that JICA training, it's called sunrise training. They train seriously, intensively the 20 key farmers. And then those key farmers are trained like 12 days in the nearby training center. And then these key farmers are expected to invite 5 intermediate farmers each. And they have a joint training session in their irrigation scheme. And then it lasts 3 days. And then intermediary farmers all the farmers are invited just for demonstrations. And intermediary farmers are also expected to train those ordinary farmers. So what I'd like to know is if this kind of dissemination process will work effectively or not. Okay, so this is a bit of picture from Tanzania. And in Tanzania, there is one variety. In fact, there is almost only one modern variety which is accepted in Tanzania. which is called Salo 5. And this variety is released in 2003. And it's started diffusing especially in irrigated area. And as you may know, of course, the transplanting is very important to facilitate the weeding. And if you transplanting low, the weeding becomes much easier, and also you can control the population of the plant. And this picture is to show the importance of leveling. And if the plot is not well leveled, the growth of rice becoming uneven, and there are some parts where rice is not growing very well. So this is the same place where, which is properly leveled after the leveling, then the growth of the paddy becomes very even and the paddy becomes very well developed now. So those are the technologies that I'm talking about. And that in fact is a trained in internal training also. Okay, this is a picture of the village. And this is in fact it's the center of the village. And there is no restaurant there, and I usually eat there. Then this is the training course done by JICA. And these are the farmers who are invited to the training course, and they are learning what is the ideal situation of the rice cultivation. And in actual sense, their field looks like this. It's a little bit difficult to tell whether it is transplanted in low or, but at least it is an irrigation scheme. They have a bit of nice kind of irrigation channel here. But it also depends on the farmers. And this is a bit difficult to tell because I couldn't get a picture in the wet season. But from this picture, what you can tell is that some part of the irrigation scheme is not well developed yet, and their band is quite big. You cannot even distinguish whether it is band or not. And sometimes, the leaking from the water from the paddy field is quite serious. So this is, there's quite a bit of variation in the situations of the farmers' management in the field. Okay. Now we can see this situation in the data. Sorry that the table is a little big, but this is the table which shows the technology adoptions and paddy yield of key farmer, intermediary farmer, and ordinary farmer. And then in 2008 is before the training. It's equal data, but it is before the training. And training was done in 2009. And then we are conducting survey and collecting data of 2010. So the first survey was conducted in 2010. And in fact, I have I collected the data every year when I was in Tanzania. So I have the data of 2010 and 2011 and 2012. But because of the limited space, I just show the data of 2010 and 2011 in this period. Okay. What you can see from here is that key farmer achieve very high yield after the training. And then it is not really because key farmers, of course, key farmers are the one who is a little bit advanced even before the training. But what you can see from this figure is that the impact of the training is quite big compared to in key farmers, because intermediary farmers and ordinary farmers yield doesn't really increase a lot from 2008 to 2010, but key farmers yield has increased a lot. And 5 ton per hectare is a quite good achievement that shows that there is a high potential for the green revolution in Africa, as long as they use the proper technologies. And then adoption of modern variety increased also. And this line knowledge shows that after the training, whether they are aware about these technologies or not. And when you see this, in terms of knowledge, key farmers and intermediaries are almost perfect. So after the training, they know all these advanced technologies. So the problem is how much they adapt, and then how these technologies diffuse to ordinary farmers who didn't really get the training. And in terms of modern variety, adoption increased from 46% to 63% for the key farmers. And then even for intermediary farmers, there is a slight increase in the adoption of modern variety after the training. But for ordinary farmers, the information, it seems that adoption really didn't increase after the training for the modern variety. Okay. And for the improved band, it is a band which is a bit wide and it's compacted with soil. So it's a strong band which doesn't really, it's for Asian context, maybe it's a bit difficult to understand, but it's compacted and a strong band which doesn't really release the water. And in terms of that technology, in fact, this is quite new to everybody. And key farmers, 23% of key farmers are adopting that new technologies, and 16.7%. But ordinary farmers adopt only 4.5%. But over time, when you see the adoption, it slowly increased from 2010 to 2011. And share of the level plot, in fact, the leveling is not really a new technology, and some of them already have adopted even before the training. But adoption increased after the training a lot. So probably that can be one the impact of training that leveling has diffusing now. And then there is another technology which is like leveling, but they use with a kind of board to make the soil flat. And then they teach it in time-lapse training, but this didn't diffuse at all. And very few farmers adopted, and then in the next year they just forget about it. So this technology didn't diffuse at all. And then this is the share of the household who adopted transplanting indoor. And before the training, the transplanting indoor was not diffused. The adoption rate was quite low before the training. But after the training, the transplanting indoor diffused very rapidly, especially for key and intermediate farmers. But and then there are some moderate increase in the adoption of transplanting indoor for ordinary farmers also. So what I can summarize from this table is that key farmers are adopting most of the technologies and they achieve very high yield. But for intermediate farmers and ordinary farmers, the adoption, at least key farmers knows all these technologies, but adoption is not as rapid as, of course, key farmers. So what I would like to know is what is the determinant of, how this technology, which is installed by key farmers, are diffused. Okay. And then this is the table which shows the information source of these technologies. And here I divide the sample into two groups, key and intermediate farmers and ordinary farmers. And what you can see from this figure is that, this is only adapters, so subsample. So those who adapt this technology get information from where. So that is this table explains. And what we can see from this figure is that for key and intermediate farmers, all these new technologies, most of them are taught in time-lapse training. So after they get information from time-lapse training, they adapted new technologies. And only leveling, I told you that the leveling is not really a new technology. They knew from their own experience and by observing other people, they already knew the technologies. So all these three technologies, including modern variety and improved land and transplanting indoor, farmers learn from turn experiments. Okay. Oh, am I clear? Okay. Then for the ordinary farmers, this is on experience and observing, and this is informal conversation with other farmers, knowledge training and other information source, including mass media and other training. What we can see from here is that adapters of modern, most of the information source, even for the adapters, is observing others, or at least informal conversations. So they didn't. There was a one-day session for them, which is open to the ordinary farmers also. But basically, they are learning from observing other people. So I would like to know if this observing is really effective. Then the technology taught by key and intermediary farmers should diffuse to ordinary farmers. Okay. And then in order to examine this point, this table shows that I divide a sample into two groups, and one is this table shows the adoption of only ordinary farmers, okay? And then this one is the one who gets some information on technology, and specific technology, from key or intermediary farmers. And then those are the ordinary farmers who says, I didn't learn any technology from those, these key and intermediary farmers. And in fact, I asked all the relationship with all the key farmers and the intermediary farmers with everybody. So I asked them one by one, did you learn any new technology from them? Did you learn modern variety from them? I asked all the key and intermediary farmers in the interview. So, and then based on that information, we divide the sample into key and those who get any information from key or intermediate, and those who didn't get any information from key and intermediate farmers. And then, so those who learn technology from key farmers, this is the adoption rate in 2010, and this is the adoption in 2011. And this one is the figure in 2010, but what I show here is that they know the technology, but they decided not to adapt. So these farmers are one who knows the technologies, but they didn't adapt. All of them are ordinary farmers. And this one is the one, this is a bit contradictory, but they say that they don't know this technology, while they ask those technologies from key or intermediate farmers. So they say that they don't know. And then this one is they didn't learn the technology, and then the same figures. Adoption in 2010 and 2011. And in 2010 they know the technology, but they didn't adapt. And they say, some of them say that I don't know completely these technologies. And what I can see from this figure is that those who learn technologies, of course, in terms of the knowledge, there is a positive impact. This star shows the t-test examining this and this. Okay. So in terms of knowledge, those who communicated with key and intermediary farmers have better knowledge. But so in terms of modern variety and improved land and leveling is not new, so probably everybody knows. But transplanting is also. So those who communicated with key farmer has better knowledge. But when you come to the adoption itself, we see little impact. I mean, slightly, those who talk to key and intermediate farmers adapt technology more, but the difference is not big, and it is not statistically significant. So yes, communicating with key farmers increase the knowledge, but adoption still, I mean, except the transplanting in law in 2011, we don't see very strong impact of communicating with key and intermediate farmers on the adoption. So that is a finding from this table. And then who, I mean, in general, it seems that they are not really trusting key and intermediate farmers. So then whom are you going to trust? I mean, whom are you going to follow? So in order to examine that, I separated the sample into two groups. And again, this is ordinary farmers. But ordinary farmers who have at least one relative among key and intermediate farmers. And this is no relative. I mean, those who doesn't have relative at all. And then this one has, I mean, they say that, okay, these key and intermediate farmers are my neighbor. And they say that those people are not my close neighbor. And then another criteria is residential neighbor, because they commute from the village to the plot. So residential neighbor and plot neighbor is different. So here I separate the sample into two groups. Those who have residential neighbor, who is key and intermediate farmers, and those who doesn't have residential neighbor, those who don't have residential neighbor, who is key and intermediate farmers. And then we also separate another criteria is that there is any church or mosque member who is key or intermediate farmers, and there is no church or mosque member among key and intermediate farmers. And when you see this, at least you can see slight impact of adoption of technologies in terms, I mean, when they are relatives, they probably follow, okay, my relative is doing this, so let me try. So these kind of things, I mean, are there. Then the difference is not that big, but still it is significant, I mean, statistically significant. And this is in 2010, and this is 2011. And even for residential neighbor, I mean, adoption of modern variety is increased, and shared transplanting is also increased, and same church mosque member has positive impact in the level of growth. And in 2011 also there are some slight impact, although this is, I don't know, I mean, this has these are the unexpected results of negative impact of the plot neighbor, so I'm not so sure about this, but in general, I think we see the positive impact of the social network. So that is this shows. Okay. So in order to examine, the determinants of technological adoption, we estimate the statistical model also. And then in that model, we are going to capture the factors affecting technology adoption, and we also have to capture the influence of the neighbors. So this is the social learning part. And we use the spatial model. That's why I am working with Val here. And then we also include those factors. First of all, adoption depends on farmers' their own characteristics, such as age, education, and farm size. And then farmers' experience, farmers' adoption this year, 2010, probably is affected by their own experience in the previous year, which is the training year. And then in order to incorporate this effect, I include this term, yield multiplied by, this is just for model, in general, this MB must be not only MB, but technology adoption. But, adoption of last year multiplied by this year last year, yield of last year. So this is paddy yield and adoption of technologies. So that means that information of past yield is only effective when new technology is adapted. So when you adapt new technology, you know the new yield, and then that information will give you it is interpreted as a farmer's past experience of that new technology. And then we also incorporate the experience of neighbors in previous years. And then we incorporate it by multiplying this interaction term of yield and technology adoption by weighting matrix. I'm not really a spatial econometrician, but what I have understood and what I can explain to you is that this W is giving you the average of those who adapted technology in your neighborhood. And we decide the threshold distance to define the neighbors of yours. And then we are taking the average of past yield multiplied by technology of those neighbors within the threshold distance. So that is to capture the experience of neighbors. And then we also would like to separately capture the influence of key and intermediary farmers. So we include those variables of key and intermediary farmers, and here we determine we define the impact of the nearest key and intermediary farmers as the paddy yield of the nearest adapters. So nearest key farmers. So yield of nearest key farmers who adapt new technology. So after they adapt new technology, you observe that yield, and then if that yield is high, then you have more incentive to adapt. And if that yield is not really high, then they just forget about it. So in order to capture that, we include the yield of the nearest adapters among key farmers and nearest adapters among intermediary farmers. And then since we observe a bit of positive impact of the relationship with key and intermediary farmers, we also control that relationship with key and intermediary farmers. Okay, so this is how Bar calculated the weight matrix. And as already told you, we calculate the minimum threshold of distance, and that is 0.77, sorry, this is miles. To ensure all the farmers have at least one neighbor, because otherwise, if the matrix becomes all zero, then we cannot calculate the average. So we define the minimum distance to ensure at least one farmer, all the farmers have one neighbor, and then we define we calculate the average, of those variables of neighbors. So those who are within this distance are defined as neighbors, and we are taking that average by multiplying this matrix. And the matrix is all standardized. If you know what you want to know in detail about this, please ask, but not me. Okay. And then, as the farmer's characteristics, we include all these standard variables like age of household head, average years of schooling of adult household members, and female-headed household to capture the human capital endowment of household. And we also include the size of the plot and size of other old plot. Size of other old plot means except the sample plot. And value of household assets and area, dummy of which shows the area which the plot located in the irrigation schemes, and farmer time dummy. So we include all these basic informations in our regressions, although I don't show the results of these. Okay. Then we apply this model to 3 types of data sets. And it's all the matter of whether we include what type of farmers. And then the first type of data include all the farmers, including key farmers, intermediary, and ordinary farmers. And social learning impact is captured by weight matrix of all the sample. And then the feature of this data set is that we do not consider the difference in the farmer type. So key and intermediary farmers adoption is treated as the same as ordinary farmers. So this is a kind of similar approach to the existing literature, which doesn't really care who that kind of, who is those farmers. Whether they are trained or they are not trained, they just think that adapters are adapters. So this, first data is similar to what existing literatures are doing. And then the second data set only includes intermediary and ordinary farmers. So we exclude the key farmers so that we can capture the impact of the key and intermediary and key farmers and intermediary and ordinary farmers separately, because key farmers are trained, very special farmers. So if we include them all together, then we cannot see the differential impact of key and intermediary farmers. So in order to separate the impact of key farmers, we only include the key and intermediary ordinary farmers in the sample. But so in order to capture the influence of key farmers, we specifically include the distance to the nearest adapters of technology among key farmers, and also yield of the adapters of technology among key farmers. So if those variables are significant, that means that the farmers are learning from key and key farmers. So we can separately examine the impact of key farmers. The difference between data 1 and data 2 is that you can exclusively examine the impact of key farmers. And then, of course, the neighborhood impact is examined by including the social matrix of ordinary and intermediate farmers only, because the now sample is ordinary and intermediary, so the weight matrix also becomes ordinary, only include ordinary and intermediate. And then the third data set is include only ordinary farmers. So we can see the impact from key and intermediate farmers separately. And although I didn't write here, of course we include the neighborhood effect only among ordinary farmers. So how much ordinary farmers learn from themselves can be captured in this node. Okay, so am I clear? Is there any question? Sorry, I took too fast. Okay. Okay, then let me show you the results. Okay, so here is the data from the data set 1, which includes all key, intermediary, and ordinary farmers. And then I showed only key variables. So this is if he or she, that sample farmers have relative among key and intermediate farmers. So I still control this kind of social relationship impact with key and intermediate farmers, though all of them are included. Okay. And then this is same church or mosque member, and this is residential neighbor. And then the most important part is, this one. Yield multiplied by adoption in 2009. This shows the own experience. If you remember correctly, this one. Let me go back a little bit.
I'd just like to ask a quick question. The
Yes.
2009, is that the recall data or is that the 2010 survey?
2010 survey, 2009 is record data.
Recall data.
Yes.
Okay.
Right, yes, it's record data. So, right. So, this yield multiplied by modern variety is your own experience. Okay? And then, this W, when you include W matrix with this, then it captures the social impact, social learning impact. So this yield multiplied by yield in 2009, this is your own experience. And then this is the social learning impact. The most important finding here is that, okay, your own experience matters for all the technologies. And social learning matters when you include all farmers, intermediary, key, and ordinary farmers in the sample, then the social learning or modern variety is there. But we don't see social learning impact on different technologies. So that is the result from the first data. And when you see the second data which includes ordinary and intermediary, then we have that this is their own experience, and this is their social learning impact from ordinary and intermediary. And then this is the paddy yield of the nearest adapter of the modern variety among key farmers. So this is paddy yield, okay, paddy yield of the nearest adapters of the modern variety among, technologies among key farmers, technology in general, sorry. And distance to the nearest adapter to the technology adapters among key farmers. So this captures the impact of the key farmers. And this is the social learning effect, and this is your own experience. And again, what you can see from here is that your own experience matters. And although the significance decline, we still see the impact of social learning on modern variety adoption. And when you, this should be leveling, sorry. Sorry, there are many mistakes because it's the first time for me to present this. This one, it should be on the leveling impact, this one should be leveling. And same chat most members among key and intermediary farmers has positive impact on the leveling, plot leveling, not include one, but sorry. And then this is the result from the third data. And then, so third data includes only ordinary farmers. So we capture the impact of key adapters of the key farmers and intermediary farmers separately. So we include the paddy yield of the nearest adapters among key farmers and paddy yield of nearest adapters of this technology this is adapters of modern technologies of intermediate farmers, okay? So, and then the distance to the nearest adapter among key farmers and distance to the nearest adapters among intermediate farmers. So, we separately include the impact of key and intermediate farmers. And this social learning effect can be interpreted as a social learning among only ordinary farmers. And then when you see this results, what you can see is again the past experience of these technologies very important determinants as it's very important determinants of the technology adoption. And then you don't see the social learning effect at all among ordinary farmers. So it's still pretty much difficult for the ordinary farmers to learn new technology among themselves. So if I exclude key and intermediate farmers, that neighborhood effect cannot be observed. And those impact from key farmers And intermediary farmers can be observed here in transplanting indoor only. And that means that they are adapting new, there are some of the key farmers are adapting and they are achieving high yield. Then you also try to mimic the technology. And these are in fact in 2009. So based on previous years, what they observed, then they decide to adapt transplanting indoor, as long as your nearest adapters are achieving high yield. So there's some, I guess farmers are observing the performance of adapters, and then they decide whether to adapt or not. Okay. So in general, okay, I think in general what we observe is that I guess I better explain this first. So in fact, we just started analyzing this data series. So I was in Tanzania, so we didn't have time to work together with Vlad, and we just started this analysis. So the conclusion is still tentative, but what we can say from this analysis is that rapid technology adoption and high yield is, the technology is adopted very rapidly by key farmers, and then they are achieving very high yield. So high potential to the green revolution in Africa, because as long as proper technologies are adopted, then they can achieve very high yield. So there is a big potential for the green revolution in Africa, especially in irrigated areas. And then we observe that all experience is very important determinants. And then in general, there is a very limited information spillover from ordinary to ordinary farmers. As you can see from this table, okay, there's no spillover impact at all among ordinary farmers. So for ordinary farmers, from ordinary to ordinary farmers, if you let the technology go, it really don't go. So at least key farmers and intermediary farmers are probably important for the initial point of the technologies. And then information from key and intermediate to ordinary farmers, at least for several technologies. And especially in the adoption of transplanting indoor, we observe positive impact of the yield of this one. We observe the positive impact of the nearest adapters yield has positive impact of adoption in transplanting indoor, which is a kind of evidence that informations are growing. And then what is mixing is the social networks. Okay, and then there is a social network effect with key and intermediate farmers, which affect the revenue. Okay. And then, which is a bit mixing for me, is the plot neighbors' experience of modern varieties. Remember that the coefficient of, their own experience, not own experience, neighbors' experience is positive when you include all the farmers, including key and intermediary, and then ordinary farmers. And then it becomes less significant, but it's still significant when you include intermediary and ordinary farmers. But if you see the social network effect only in ordinary farmers, then the impact becomes insignificant. So probably key and intermediary farmers are kind of playing a role of catalyst. They does not strongly influence the ordinary farmers, and this technology adoption process takes a little bit of time. So they play at least some role, but we cannot strongly argue that key and intermediary farmers are influenced to ordinary farmers' role, adoption. And then when I think about why only transplanting in law has that kind of positive impact, then I came some idea for that, the reason for that. And this is, in fact, is a table from different studies which I and K is working on, and in the same study site, and using the data of 2010 and 2011, which I showed you. And what the finding from this paper is that transplanting in law increases income from rice per hectare. So, and then modern variety increases the income from income per hectare, income from rice per hectare, only when it is adapted with improved band. So transplanting in law is kind of easy technology. Most of them have already transplanted. They are randomly transplanting already. So once they observe, if it is in transplanted in law, it's very easy to observe. And then also, transplanting in law has positive impact on the income. So that probably means that the farmers are very quickly adapting new technology which is profitable and observable. And for modern variety, it requires the good water control. And in fact, the sulfide requires a lot of water, so it should be planted with good water control. So it's probably not so easy as transplanting in law to increase the income by using modern variety. So that's probably the reason why the adoption of modern variety is a little bit slower than transplanting in law. So if you want to rely on farmer-to-farmers dissemination strategy, I think the visibility and profitability and visibility of technology would be an important determinant for those new technology emission if you want to rely on farmers-to-farmers dissemination strategy. Okay. In fact, since our analysis has just started, there are so many things that I think we can do. And then in the future, in the near future, I want to incorporate the changes in the adoption over time. As already told you, I have 3-year panel data, but right now the analysis is still cross-section. It's partly because those variables of social networks kind of thing is time invariant, so it's a little bit difficult to use panel data. But at least we can utilize the full cross-section data to examine those adoption behavior change over time. And then another thing is that adoption conditional of the knowledge. And then we can use a Heckman two-stage model to, this one means that those who don't know the technology can never adopt technology. So we first estimate the knowledge, and then we estimate the impact of the adoption, the determinants of adoption conditional to knowledge. So that can be done with Heckman two-stage model, and that one also we can incorporate. And also, since we are using the, most simplest version of a weight matrix, we can use the different weight matrix. I'm sure that Val will help me to find out this. And then we can use the different type of weight matrix to capture the impact of key, and then also we should also think about, right now we are capturing impact of key and intermediary farmers by the distance to the nearest adapters and yield of the nearest adapters, but I think we must think about alternative way to capture their impact. And then we can also incorporate the spatial error model, and this one is very important because in the literature, the control for covariate shocks, those who are near the one who face the same shock, so those things can be controlled by spatial error model, so we have to incorporate that in the near future. And then we also can develop a bit more fashionable model by using the yield gap. Right now, it's just a simple interaction term of yield and adoption of technologies, but we can examine the impact a little bit more in a sophisticated manner by incorporating the yield gap between you and adapters, or those who didn't adapt the technologies and adapters. So we can calculate more rigorously to capture the impact of success. I mean, how you define success can be a little bit more sophisticated by using yield gap. And then, in fact, this paper, it is out of this paper, but this paper doesn't really try to assess the impact of timelines because we don't have the data before the timelines training. So it's very difficult for us to do the rigorous impact assessment of timelines training. But we have a data, as I already told you, the survey was conducted in 3 irrigation schemes. And then, luckily enough, timelines training was done after data collection in one of our study sites. So we can do a bit more rigorous impact assessment of timelines training by using that data. And in fact, I collected a lot of data in this study site, and then I have added a lot more experimental studies and all these programs. So just wait for a moment for other papers. Okay, thank you very much.
Well, we started at 10:35, so let's take 5 minutes for question and answer. Quick question, for 3 questions we can take. Yep. Yes, please go, David.
Yeah, maybe I don't need a microphone. Thank you for a nice presentation. I guess this will be a compound question to try and be one question. So you can address whichever part of it you want. I guess one thing I wondered about is whether we're in a little bit of thin ice here because we're working with recall data for a lot of the spatial regression. And a lot of your conclusions are drawn from transplanting, and transplanting doesn't have also many adoption observations among ordinary farmers. So out of 170 farmers in the total sample pool, I think how many farmer observations based on recall are we working with there? And also we're dealing with a set of technologies where for most of the technologies, even before the project, there was knowledge of most of the technologies, and what we see as the trajectory is disadoption. So there's a spike upwards with the project, but then the trend seems to be going back towards the prior perceptions anyway, which makes me think that maybe the key farmers had some incentives to try these technologies. So I wondered how those issues might affect your findings.
Okay. So should I answer?
Yeah, please.
Okay, right. That's true. We are relying on record data, but I mean, if we do 2010 to 2011 comparisons, then it's or we don't need to rely on record data because we have already conducted survey. So I think we can incorporate that point by analyzing change in 2010 to 2011, because it's not really an impact assessment. So diffusion process doesn't really depend on the I mean, as long as it's after the training, I think it would be okay. So that can be incorporated, and
I guess there you'll run into the problem of few observations because there's not a big change in the adoption rates.
That's true.
Anyway, sorry.
Yeah, that I think. Okay.
Yes, please.
And
Is okay?
the second
Yeah,
question
go ahead.
is? Sorry.
You can answer later, no problem.
Okay.
You'll be here, right, for few days.
I have to.
Anyway, Yuko, thank you for the nice presentation. My question goes to one of the table you saw initially,
Table one.
with all the different technology intervention there.
Go to table one.
MBs, bonds, labeling, and row transplanting. When I saw the fertilizer used per kilograms, it increased quite a bit from 2008 to 2011, like a 3-4-fold increase. Was it related to MB adoption, or it just you never talked about anything about the fertilizer application?
the reason why I didn't ask them about the knowledge
I
of
think it's
fertilizer.
not your, I think it's the initial table, first table.
They know it.
It's like 18 kilograms to 100, wait here.
Right.
60
Yeah, right.
kilograms to 180 kilograms,
Right.
18 to 100. So it's like
That's
3-4
true.
fold increase in fertilizer use.
And part of the reason, not all probably, is that they have a fertilizer subsidy program.
Or is it linked to what David was mentioning, that there is an incentive for the key farmers?
Right.
You give free fertilizer to these guys. Free key farmers.
No. They don't distribute fertilizer at all in the training.
To the projects.
But they have a fertilizer training, fertilizer subsidy in 2010, so that might affect this. But when you see the recall data of 2009, it also, the chemical fertilizer also has increased. So I think it's difficult to separate the impact because we are in the same study site, but part of the reason must be this subsidy and part of the reason must
So
be
is this the national trend? You know, if you in Tanzania, if you look at average per capita, average fertilizer use per hectare, is this the way the trend will be, or is just a specific thing?
I have to check it. In
Yeah,
fact,
I'm wondering the yield has gone up quite a bit in the last few years.
No. In fact, I conducted survey in a little bit more national representative setting,
So it
and
is
then I compared 2009 to 2012. But there is not much change.
in fertilizer use. So this is very unusual.
Yeah, kind of.
I have a small question actually. You see the share of modern variety has declined in 2010 compared
2011, right?
Yes. So it's
Probably,
after training.
Then 2010 has, there is a water shortage in 2010.
Water shortages.
Yes, and then modern variety, Saro 5 has a feature that they require a lot of water compared to traditional variety.
Yes.
So probably they failed in 2010 to grow modern variety without, I told you modern variety has no positive impact without good water management.
Yes.
So probably after they failed in 2010, they are a bit reluctant to adapt modern variety again in 2000. That's my guess.
You did not isolate the effects of different things on yield. You don't have an equation like that. No.
You mean
That irrigation.
What is contributing to the increase in the yield?
no, we don't have.
But it's mostly
No, but we have this one. We estimated the model, and then chemical fertilizer. This one is basically the result of the same as yield also. So, and then this is panel data, so we can estimate kind of production function without endogenetic problems. And then chemical fertilizer has positive. And then this is the dependent variable now is income, but we have similar analysis for yield.
Okay. Any question from this side? No question? None? Any burning question?
Now, from your result, what will you conclude are the two most important factors that will affect adoption of this technology?
Oh, two most.
Yeah, based on
Okay, from this analysis, what I can say is, first of all, direct training is very important. Direct training. Directly train farmers, adapt technologies, a lot. So, extension service is very important. But the problem is that we cannot train all the farmers. So, what would be how much the technology diffuse must be examined. And then for the modern variety is difficult to conclude, but at least ordinary farmers are not adapting a lot. If you see this, the adoption rate doesn't really increase. So, just observing, by observing, modern variety doesn't really diffuse. That is my impression. But for transplanting grow, probably they can observe.
Yeah.
So probably the farmer-to-farmer extension would work for this technology, which is visible and it's easy to follow.
Yeah, thank you very much for a nice presentation. Let's do it. There is no media, sorry, because of the afternoon there will be program.